Let's discuss another question from strength of materials. So this is again on thermal side. Okay, so basically you have a rod, axial rod, which is supported on both sides. Okay, axial rod, where you have springs on both sides. So okay, and now the entire system is heated to 20 degrees rise in temperature. Now because of the rise in temperature, this will expand, this will expand. Okay, but the spring which are free initially now will compress, so they try to oppose and they provide a force in this direction, okay, on both sides. Because of that, there's a compression set up in this rod. Okay, so now what we do is we'll just find out how much is the thermal strain. Okay, so thermal strain is basically is okay, or thermal change in length. So this is alpha delta t, whereas the change in the thermal is L alpha delta t, right? Strain into length. So this is L alpha delta t. Length is given as your 0.5 meters, alpha is given as 12.5 into 10 power minus 6, and delta t is basically 20 degrees. So this value comes out to be, so 0.5 meters, so into 10 power 3 I will do in order to convert in mm. So 0.5, so this is for the length mm, alpha delta t. So this value comes out to be 0.125 mm. So 0.125 mm is the thermal change in length. Now because it's change in length, there is the springs get compressed. Now this delta t is the total change in length. So if you have a rod here and it can easily expand in both directions, so here it will be delta by 2 and here it will be delta by 2. Half of this will be felt on both sides. So you have a spring here, so the spring, when you compress the spring by delta 2, the spring will exert a force which is k into delta by 2, and the same thing here, the spring will exert an opposite force being k into delta by 2. So this p is what is acting on the rod as a compressive force, and because of that you get the stress. So let's first find out this p, k into delta by 2. K is given as 50, spring constant is given as 50 kilonewtons, so 50 kilonewtons, so 10 power 3, okay, by meter. So meter is 1 into delta, so we have to use now delta in meter, so 0.125 into meter, so 10 power minus 3 by 2. So remember, don't forget that 2 because it's delta by 2 on both the sides. So that is 25 into 0.125. So this value you get about 3.125 Newton. 3.125 because 10 power 3, 10 power minus 3 gets cancelled. You get 25 into 0.1. So basically 3.125. Now the stress will be the compressive, because this load is minus p on both the sides, minus p by area, and minus p is minus 3.125 by area. Area is pi by 4, and let's look at the dia. Dia is 100 mm, so 100 mm whole square, so it is Newton per mm square, and then you have to convert because what is asked is in Newton per meter. So if you calculate this, or here only because it's asked in Newton per meter square, so mm square, and then you, or you have to just use 0.1. okay, so let's write here minus 3.125 because it's asked in Newton per meter square, so use pi by 4, diameter in Newton in meter, so 0.1 whole square. So this value comes about 398 Newton per meter square. So answer is, and minus, that is important because it's a compressive force, so minus 398 Newton per meter square is the actual stress induced. Thank you.